Here's a question that might be similar to one of your homework problems. We are supposed to rank the potentials at these 4 points, A, B, C, and D. And we know that they are equidistant from these charges. So there's two equal positive charges here and here, and then a negative charge that's equal in magnitude over here. And we can call each distance between the point and the charge next to it distance D. So we got D here, D here, D here, D here. And all we have to do is rank the potentials at these points, A, B, C, and D. So we don't need to actually know real numbers here. Let's use the equation for potential that I derived in the last video. Which is this. So if we're going to find the total potential at point A, we have to sum up the potentials from each of these 3 point charges. KQ over D would be the potential at point A from this charge right here, because that's a charge of Q magnitude a distance D away. But then there's also other charges, such as this charge Q, which is 3D away, so we have to add the potential KQ over 3D, and then there's this last third charge that is, let's see, 1, 2, 3, 4, 5D away, and that is a negative charge. So we can either think of it as being K times negative Q over 5D, or we could just think of it as subtracting KQ over 5D. And we can write this equation like this, which lets us see that we're really just summing up the number of KQ over D's that there are. So if we add 1 plus a third minus a fifth, we get 1.13 KQ over D's. Now let's look at point B. Alright, point B is a distance D from this positive point charge. So the potential from that point charge is KQ over D. It's a distance D from this point charge. So we got another KQ over D. And then B is a distance of 3D from a negative point charge. So because it's a negative, we subtract. And that's a distance 3D away. So we add all those up, we got, here we have 2 KQ over D's, then minus a third KQ over D. So the potential at point B is a total of 1.67 KQ over D's. So now our last thing to do is put also the potential at points C and D in terms of the number of KQ over D's. I'm going to skip finding the potential at point C. I'm going to go right to point D, because I think it's going to be, it's kind of clearly the lowest potential, because it's nearest to the negative charge and farthest from the positive charges. Its potential from this positive point charge is KQ over 5D, because it's 5D away. And then its potential from this charge is KQ over 3D. And then its potential from the negative charge right next to it is negative KQ over D. So when we sum all those up, we get negative 0.47 KQ over D. So we have all these potentials in terms of KQ over D. So no matter what K is and Q is and D is, we can rank them. We still know that we got a negative number here. This potential is the smallest. And then the potential at point B is, I don't know, so far it's the biggest. It's definitely bigger than at point A, because no matter what K, Q, and D are, 1.67 of them is going to be more than 1.13 of them, which is what we had at point A.
Made with Doodlecast Pro.